Hello everyone, my name is Andrew, and in this presentation I'm going to discuss what I've been doing this summer under the Kids' Lab. So for background, the Kids' Lab uses audio recorders to study birds, and my bird of focus was the ovenbird species for various reasons, and the challenge was that we wanted to measure the amount of aggressive interactions between different ovenbird individuals. And the approach was to use acoustic localization and machine learning techniques to detect birds. So previously, the Kids' Lab developed an individual classification device on ovenbirds that allowed ovenbird bird songs to be mapped to ovenbird individuals. So my extension of this is to create a network graph that would allow us to study the underlying structure of ovenbird behavior, such as aggression, for instance. So the pipeline that I ran is essentially hawk ears first, data, individual, and then for my main contribution, I made an ovenbird network, I analyzed the network, and then I collected some metrics. So essentially these are some features within the songs that the classifiers picked up, and time TDOA is a mechanism that was used. So for my individual classification of results that I ran using the Kids' Lab's previous developments, I found that this array had the most amount of sort of individuals. And so I defined my network to have an interaction criteria of a fight has occurred between two birds if their events occur within a fixed time t of each other, and they have to occur within a fixed distance of each other. So I found for network interactions these results. You can see that this array has a ton of interactions, while a lot of the other ones didn't have many interactions at all. And this is a graph visualization, and as you can see, these two individuals have the most amount of interactions. And these are the network metrics. You can see that there's higher density here, and the key takeaways is that different individuals have the different amounts of results, and that these two individuals had the more frequent amount of interactions, and that more interactions imply a higher probability of a fight. So limitations that data is too few, which severely limited the scope of the research. The research itself is genuinely new, so there's no historical baseline to compare it to, and many components are automated, and it needs to be human verified. So next steps is to increase the data and then fit more network models. And I would like to thank Dr. Rahimian, Dr. Kitts, Louis, and Sam, whose novel individual identification pipeline made this project possible.